हो गया. Just see. आ गया. हो गया. Hi, hello everyone. Hello everyone. Am I audible and visible to you? A very warm welcome to Deeksha Vedantu YouTube channel. I hope you all are doing really great. How are you? Hi AKA, I'm great. Hi class C. Hello everyone. Hello noob gamer. Hi everyone. So today we have come up with a live for the chapter Human Eye, and we are here to revise this chapter as well as to see lots of questions from this chapter. Those will be most expected and your PYQs. I want you to share this live with your friends, with your cousins, so that they can also join. This will be a very important live, since we have covered in this GOAT series. We have covered 3 chapters already for physics. Those are light, electricity, magnetic effects of electric current, and now we are here for human eye, where we revised the chapter first and then we moved on to the most important questions of that particular chapter. So overall in this series you have completed how many? You have completed almost 45 questions of physics. Hi everyone. Hi Trev. Hi honey. Hello. I'm great. Okay, so can we start the live? Give me a thumbs up if we can start the live. Hello everyone. Okay, we will start this with mind map, with revision. Mind map, basically why? Because they are very easy to remember and you can use them to recall the stuff very easily. Okay, now this picture I have used before, and I know you definitely, a lot of people I know, they watch animes and stuff, so I thought I'll take an image from that. Can you see in these, of course this is of a boy and this is of a girl, but they have different eye color, correct? And this is because due to a certain region of our human eye that we'll definitely study later. You might like blue eyes, green eyes. That's because of that particular part. And when we move on to the diagram of human eye, you tell me which part of our eye is responsible for the color of our eye. Hello everyone. Hello. Okay, let's start our chapter with the very first, that is human eye. Now our eye has different parts. Let's start with the first part of our eye. Okay, so if you open your eye and you touch the inside of your eye, the first thing, don't do it, it's not hygienic and stuff. If hi everyone. Okay, so the first part that you can touch with your eye, with your hand of your eye, is what? It is my cornea. It is cornea. So cornea is basically a liquidy fluidy layer of the eye which is on the front of our eye. This bulge, this is the first layer of this bulge, is called cornea, and this is responsible for the major refraction that is happening inside our eye. Cornea does the major part of refraction for our eye. It converges the rays. What converges the rays? Most of the rays are converged by cornea, correct? Okay, now the second part, when we move on, is that is aqueous humor. Now aqueous humor, okay, before that we'll study iris and pupil. Now pupil is the part, light is coming and it's entering into my eye. Pupil is the part which decides how much light will enter inside the eye. If we have lots of brightness, pupil, size of pupil gets small. If we have small light, when we enter into a dark room, let's say, my pupil gets enlarged. And who controls the size of this pupil? That is iris. Pupil is like a shutter which decides how much light can enter into the eye. And then, yes, we'll move on to the vitreous humor. This is the example. How else do you want me to give the example? We'll try to definitely get a model of actual human eye. We are working on that. Just be with us, okay? So pupil is like a shutter which decides how much light will enter into my eye, and what controls that shutter? That is iris. Now remember, I asked you which part controls this eye. I have already explained that. I'll ask you after we learn about all the parts of the eye. Next is aqueous humor. Aqueous humor is a fluid. It is a fluid between cornea and my eye lens. Okay, it is a fluid between cornea and eye lens, and it basically supplies the nutrients, supplies oxygen from air to my eye lens. Okay, and it helps in maintaining the required pressure that is required for our eye lens to be in the definite shape. Correct? Then we move on to crystalline lens. This is just my eye lens that is used to focus the light rays onto a screen where we finally see the image. So it is just a lens which helps us to focus light rays on the screen. Then we move on to ciliary muscles. Now this eye lens, there is a very important property of this lens, that is what? It can change its shape. Right? It can get thin, it can get thick, it can increase its focal length, it can decrease its focal length according to the situation presented. Now, what helps in the thickening or the thinning of this lens? That is our ciliary muscles. So ciliary muscles are just this. Ciliary muscles are just holding our lens in position, and if the lens has to become thin, it relaxes. If our lens has to become thin, it contracts. Correct? Okay. Next is our retina. Before that, it's vitreous humor. Now we know aqueous humor is the fluid between cornea and my eye lens. There is one more fluid which is present between my lens, the eye lens, and the screen. That is my screen where the image is formed. This is my eye lens. So this whole part is filled with a fluid that is called vitreous humor, and it basically maintains the shape of the eye so that it doesn't get, how do you say, pichak. Okay, so this is what vitreous humor is filled with. This is the function of vitreous humor. Then this screen that I'm talking about, this screen is where the image is formed, and this screen is called retina. It has some light sensitive cells that are rods and cones which helps to identify the brightness, the intensity and color of the light that is being incident on this retina. Okay, so this is just a screen where the image is formed. Now after that, this optic nerve, what does this optic nerve does? This optic nerve then convert that actual image into a signal and transfers it to our brain so that our brain can think that yes, the object in front of me is a camera, okay, or this is a stylus, or this is a human eye, or those are pretty skies. Correct? And these are my pretty kids. Okay, so this is what the function of all the things, all the parts of a human eye. Is this understand? Until here everyone understood everything what you guys are talking about? Okay, ma'am, can you okay, can we move on to the next part? This is where we are done with the functions of different parts of human eye. And now, what was the one part that is responsible for the color of our eye? That is responsible for the color of our eye. That part is, can you let me know in the live chat, what is the part which is responsible for the beautiful color of your eyes? We Indians, I think, majorly have blackish, brownish because of our genes, and I'm not sure how many people in India do have blue or green eyes. Okay, so this part, the color of our eye, is mainly responsible due to the part of our eye that is called iris. Iris, what did iris do? Iris controls the size of, controls the pupil, which helps us to control the amount of light that is entering into our eye. Correct? It's actually iris, not pupil, it's iris. Not cornea, not pupil, it's iris. Okay, yes, it's iris, everyone. Okay, let's move on to the next part, which is a very important topic, power of accommodation. So, power of accommodation was nothing but the ability of our eye lens. The ability of our eye lens to change its shape, you can say, but technically you should say to change its focal length according to the situation or according to the object distance presented in front of it. That is what power of accommodation is. Now, these muscles we are talking about here, what controlled the size of lens? That are ciliary muscles. Correct? Now, if my ciliary muscles relax, the lens becomes thin. Correct? When lens becomes thin, its focal length increases. Definitely, this thin eye lens has more focal length than this thick eye lens. Correct? So we can see distant objects clearly. Then if my muscles contract, then the eye lens becomes thick and focal length decreases. It has definitely less focal length than this one, and we can thus see nearby objects very, very clearly. Correct? Yes. Okay. Next is, yes. Next we are on the defects of our eye. Now what happens is, for a normal human eye, for a correct human eye, a human can see objects clearly up till infinity, and it can see objects clearly up till 25 centimeter. If you place an object at 20 centimeter from the eye lens, you won't be able to see. You would have seen, if you keep your book here to read, you must have seen that your eyes starts to get crampy. You will feel a little pain behind your eyes. So that is why, because we cannot, our lens cannot contract beyond a certain point. Correct? Power of accommodation was, my lens can contract and my lens can become enlarged. So what happens is, my lens can get relaxed. So what happens is, the eye lens cannot contract beyond a certain point. Correct? That's why we can only see objects clearly from 25 centimeter. After 25 centimeter till infinity. Okay? Next is, so some people like me, because I'm wearing a chashma, some people cannot see objects clearly, majorly in not much age, majorly when we are younger. The defect that happens is myopia. Now we'll study what myopia and hypermetropia is. So you have seen some of people like me who can't see objects who are very far away from them, let's say infinity or some definite distance, or you have seen your grandparents, they cannot read the books that are kept very close to them, maybe even 25 centimeter. So what is happening with them? Why can't they see those objects clearly? Why can't I see far away objects clearly? Why can't my grandparents can't see nearby objects clearly? That is where we study about these defects. So the first defect we are going to study is myopia, which is also called nearsightedness, which means if I cannot see far away objects clearly, but I can see near objects very clearly. Like without this chashma, I can definitely see board clearly, but I cannot see 100 meters away, correct? 100 or 200 meters away, I won't be able to read beyond a certain distance, correct? Yes, a lot of young people do have myopia, so that is myopia. Nowadays it might be increasing because we use a lot of phone, we are sitting in front of screen a lot, so what happens is our lens, it doesn't get time to relax or contract properly. That is why we are getting eye defects a lot more than we used to. But anyways, so the first defect is myopia. Now in a normal eye, what should happen, that my object is here and the rays are coming and it's getting focused on the retina. I know retina is the screen where if the image is formed, I can see clearly. But if in myopia, what happens is, so a person can see nearby objects clearly but cannot see distant objects clearly, correct? Now in myopic eye, what happens is, if the rays are coming from a far away object, they are not getting merged on the retina. Instead of getting merged on the retina, they are getting merged in front of the retina, correct? This point is definitely in front of the retina. So the image is formed in front of the retina instead of on the retina. Why is this happening? There can be some reasons. We have excessive curvature of the eye lens. This is my eye, correct? If because of any accident or something, the curvature of this eye increases. This was the eye, but the curvature increased. So at first, the image was being formed here by the lens, correct? But the curvature increased. The image is still forming here, but the curvature increased. So that is one of the reasons why the image is not being formed on the retina. Then elongation of the eyeball, my eyeball gets bigger, and excessive curvature. Okay, this was excessive curvature of the eye lens. Yeah, my bad. Excessive curvature of the eye lens means my lens, it got its curvature increased, or the focal length of this eye lens is decreased. When the focal length decreased, we know parallel rays, they converge at focus. If the focal length of my eye lens decreased, it will definitely converge before retina, correct? So that is all about myopia. Moving on to hypermetropia. Hypermetropia is nothing but the inverse of myopia, correct? So hypermetropia says, just a second, yeah. So hypermetropia says, if a person can see far objects clearly but not nearby objects clearly. Like your grandparents, they can see you standing at 100 meters away, but they are not able to read a book that is being kept at 25 centimeter, correct? So that is where hypermetropia comes into play. Hi everyone, welcome to the live session. We are moving to hypermetropia. Hypermetropia means far-sightedness, which means can see far objects clearly but cannot see nearby objects distinctly, correct? So this is the image that should form in a normal eye, correct? But if I have an object, now in hypermetropic eye, what is happening? In myopic eye, the image was formed in front of the retina, but in hypermetropic eye, the image is getting formed behind the retina. It is getting formed behind the retina instead of on the retina. That is why we get a defect which is called hypermetropia, correct? Some of the reasons: focal length of the eye lens is too long. Of course, if the focal length of my eye lens becomes large, the rays will converge at its focus, but now the focus is beyond the retina, so they will converge at this point. Or second, eyeball has become too small. This was my eyeball first, but due to some reason it got small. So the image was being formed here, but it got small, but the image is still here. That is not on the retina. So this is hypermetropia. Now to correct myopia, we use a concave lens. We use a concave lens. What it does is, why? Because the rays that are coming parallel, ideally they should converge on the retina, but they are converging in front of the retina. So what we need to do? We need to diverge them. So to diverge those rays, we use a concave lens. What it does is, the rays are coming from infinity, but my far point is now not infinity, it's let's say 40 meters, correct? So what it does is, it converges these rays back at 40 meters, then from that 40 meter rays will go into my eye, and the eye lens will focus those rays on my retina, and I will be able to see clear images, correct? Otherwise, on the other hand, hypermetropia, we use convex lens, because the rays are meeting at a point behind the retina. So I need to converge them a little more. So instead of they are meeting here, I need to converge them a little more so that they can meet here now, correct? So that's why we use a convex lens, because this is near point. This is, let's say, 25 centimeter. But now my Dadu can't see at 25 centimeter, let's say. So his near point shifted to 40 centimeter. So what this lens will do, the rays coming from this 25 centimeter, it will first converge these to 40 centimeter. Now the 40 centimeter image, these rays will again go into my eye lens now, that will get perfectly converged at the retina, correct? Okay, I don't know what you guys are talking about. Correct? Understood? We are done with both myopia and hypermetropia, correct? Moving on to the next part, which is, there is one defect left, which is presbyopia. Now presbyopia, a person who cannot see faraway objects clearly as well as nearby objects clearly. This happens due to gradual weakening of the ciliary muscles. The muscles which are holding my eye lens, these are happening due to the gradual weakening of our eye lens and diminishing flexibility of the eye lens. Very clear. And correction for myopia, we used concave lens. For hypermetropia, we use convex lens. For presbyopia, we'll use bifocal lenses. What these bifocal lenses are? They are something like this. So the lower part is used to read books, and hence the lower part is convex. The upper part of the lens is used to see distant objects clearly. So the upper part is the part which is concave lens. Correct? And it's a very important fact that, do you know that your eyes can live after your death? Not for much longer, obviously, but they can definitely live for a certain time after, not your death, I'm very sorry, of a person's death. And if the person want to donate their eyes, they can definitely do that and can then light the life of a person who cannot see. Majorly we donate, majorly the person who dies, they donate cornea, and that helps them to see light. Okay, that helps people who are not able to see the world. Okay, moving on, we have some few chotu topics left. The first one is refraction of light through a prism. So what is happening? This is my glass prism. So what happens? We have studied about refraction in the chapter light, the bending of light when it travels from one medium to another. So this is air, and inside it is glass. So light will definitely bend. So it bends towards the base, because this is the normal, and this is definitely denser than the air, and this is rarer. So it will bend towards the normal, correct? And while moving out, now this is denser and this is rarer. So it will bend away from the normal. So this is the exact path of my light ray, which is going inside which is passing inside the prism, correct? No, I am not from a South Indian state. I am actually from Punjab. I have lived here for quite some time, so I guess my accent got a little changed. Okay, so moving on, another topic a little bit, that is dispersion of white light by a glass prism. So here we just saw the path of the light that is traveling inside that is passing from a prism. Okay, there are some things. This is with the normal is angle of incidence. This is the angle of prism. This is the angle of prism. R is the angle of refraction of the R is the angle of refraction, the refracted ray. This is the angle of emergence, the angle of emergent ray, and the angle of deviation. If I expand this emergent ray beyond and this incident ray beyond, so this angle, the angle between the emergent ray and the incident ray, is called the angle of deviation. Okay. Now moving on to the next topic, which is dispersion of white light by a glass prism. So what is happening when light is going into a prism? Light has so many different wavelengths. Our white light, that is, let's say coming from sun, it has so many different wavelengths. So since this is a different medium, light will travel differently. Every light, all the colors, all the 7 colors of the light will travel differently inside a glass prism, because the speed of light changes inside after refraction. So all the colors of the light are having different wavelength, and hence they will travel with a different speed inside the glass prism, so they will get dispersed. That is dispersion of white light. That is what? Splitting of white light into its 7 constituent colors. That is called dispersion of white light into its 7 colors is the complete sentence. And when dispersion happens, we get a pattern which we call is Vibgyor. So violet, indigo, blue, green, yellow, orange and red. Okay, and red deviates the least, blue deviates the most. Correct. Now a very important phenomena that our scientists observed, that if I put a prism, white light gets dispersed. If I put another prism in front of the dispersed light, but the twist is that the prism is now inverted. Correct? The prism is now inverted. So what will happen? These 7 light colors that were dispersed, white light was dispersed into 7 colors. Now those 7 colors will be back again, and they will emerge out of the prism in form of a single light, that is white light. So if you place 2 prisms but they are inverted to each other, so you pass white light, you will get 7 colors. Those 7 colors will again pass through another inverted prism, and they will combine back into one single white light. Correct? Hi everyone, welcome to the live session. Okay, moving on to the next topic, that is formation of a rainbow. Very interesting topic. The topic is this rainbow you must have seen after rainfall, as suggested by the name. Now after rainfall, what is happening? When you see, you must have seen that in a highly rainfall region or after rainfall, you must see that the environment is a little humid. Correct? So because there are droplets, there are water droplets that are still left in our environment due to that rain. Correct? Now if my sun, this is not my sun, if there is a sun and we have water droplets here on the, if the sun is behind your back, okay, and you can see a rainbow in front of you. That is happening because water droplets are present in the air. Now what is exactly happen? Yes, ये CBSE का ही class है. Okay, so what is happening? This is my water droplet and this is a sun. Correct? So the white light, of course we know sun gives white light. This white light comes into and it enters into the water droplet. Now obviously the refractive index of a water droplet is different than refractive index of air. So what will happen? Dispersion of white light happens, or you can simply say for now refraction happens. Yes, dispersion happens. So what it does, it split into its 7 constituent colors, and inside this water droplet the light gets total internal reflection. What happens? Total internal reflection, it gets reflected but stays inside the water droplet, and then it comes out in the form of 7 constituent colors, that is VIBGYOR, and hence we see a rainbow. Correct? That is what is happening inside a water droplet to form a rainbow. Correct? Now what is happening? So what first light comes and it's getting refracting, and it's getting dispersed, then it's getting reflected, basically totally internally reflected, then again it gets refracted when it comes out of that water droplet into the air. Correct? Now two just topics remaining, that is scattering of light. So when a deviation of light from its straight path, now we know light travels in a straight path. When light is traveling in a straight path, but my environment has so many particles, those are dust, that is gas or water droplets. So when light hits those particles, dust, gas, water droplets, particles, it deviates from its original path. It is going, there comes the dust, it goes like this. Instead of going straight, it changes its path. So that is what we call simply scattering of light. Scattering is the deviation of light from its straight path when it strikes tiny particles like dust, gas or water droplets in our atmosphere. Correct? Okay, Tyndall effect. Tyndall effect says, I just find this name very funny, Tyndall. Okay, Tyndall effect says, when a beam of light strikes such fine particles, the part of beam becomes visible. Now, if you have sat in a room, not alone I'm saying, but maybe alone, and there is a small opening where the sunlight or white light or some light is coming into the room, you might have observed, you can see clearly the path of the, you can clearly see that there is a one region which is lightened by that light, and you can clearly see small particles flying around in that region only, but correct? Okay, you can share your Snapchat IDs first in my live chat. Okay. Ignoring that is what scattering of light and Tyndall effect is. Now, this is where our chapter ends. What chapter? Human eye. The human eye is a very important chapter. You must have थॉट कि इतना इम्पोर्टेंट नहीं है और इतने क्वेश्चंस नहीं आएंगे, बट दिस इज अ वेरी इंपॉर्टेंट चैप्टर. यू विल गेट questions that can bend your mind. You will get conceptual questions. Why it is important? Because in light your clear ray diagrams, some of the formulas and some of the numericals, and then electricity, lot will be focused on numericals and all that. But from this chapter you will get conceptual questions, you will get some questions that will really test your knowledge, you will get a numericals question, and you can get diagrams. So this chapter is a whole package. It might not have that much weightage as light and electricity, but still it is a very, very, very important chapter that can really make a difference in your marks. It can decide whether you will be a topper or not. This is that kind of chapter. So these are some of the questions that you should take care of. First, obviously, practice drawing the diagram of human eye. Why stars twinkle but planets do not? That is due to atmospheric refraction, where we have different layers, and in each layer the light is getting refracted towards the normal, away from the normal. So we see twinkling of stars, and stars acts as a point object, but planets do not. So the average light from the planet cancels out, and we see do not see planets twinkling. Why the color of the sky is blue? Because blue scatters the most and red does not. Why danger signals are red in color? Again, because red does not scatter that much. It can travel in a straight path to a long distance, so that we can see danger from a distance. That is why we have danger signals as red in color. Next, okay, before we move on to the questions of this chapter, which are very important. I've got you some amazing questions. They are really conceptual questions that will make you think. Now, before that, go join our WhatsApp channel, because we are coming live every day for all the subjects: math, SST, chemistry, bio, physics, and I want you to score really great in your boards. So do not miss any notification. You can come into the live session, even ask your doubts, understand, do the questions. Okay, moving on to the numericals, or not just numericals, all types of questions. So get ready to answer these questions now. Enough of your chatting. You have shared all your IDs. You can contact each other. Now focus on these questions. I want you to answer in the chat, and I want you to get your pen and paper and solve these numericals, because you will need pen and paper. Okay. Hi Yoga. Okay, first question says, read it very carefully. A person with a myopic eye. It is clearly given. Read it very carefully. A person with a myopic eye cannot see objects beyond 1.2 meter distinctly. What should be the type of corrective lens used to store proper vision? What is the type of lens that a person will use to restore its vision if it has myopia, if it's suffering from myopia? Okay, lots of you are answering A. We have one answer from Chirag, that is B. Okay, without pen and paper. Okay, you can do without pen and paper. A. Okay, a lot of you are saying A, and yes, A is definitely the correct answer. Remember, for myopia we use concave lenses. And for hypermetropia we use convex lenses. Correct? We use concave lenses for myopia. I am so proud of all of you. You gave almost all of you gave good questions, good answer. Okay, next question number 2. It is observed that power of an eye to see nearby objects as well as far off objects diminishes with age. Name the defect that is likely to arise in the eyes in such a condition. So a person, what kind of defect a person has if it cannot see nearby as well as far objects clearly? Let me know the answer. Okay, we are getting C as an answer. C is presbyopia. C. Okay, yes, we know that if we cannot see far objects clearly, that is myopia. If I cannot see nearby objects clearly, that is hypermetropia. But if a person cannot see nearby as well as far objects clearly, that is definitely presbyopia. So C is the correct answer. Very good. Okay, moving on to the next question. What happens to the image formation on the retina in case of a myopic eye? We just studied it. Read it carefully and answer it carefully. What happens to the image formation on the retina in case of myopic eye? Images formed on the retina, images formed behind the retina, or images formed in front of the retina? Let me know. Yes, we'll do hard PYQs. These are some of the basic questions that we are doing to warm up, to brush your concepts, so that you can clearly remember which lens is used for which kind of defects. Coming up, we have some really good numericals also. Okay, everyone is saying C. We have one B answer. Yes, in case of myopic eye, the image is formed definitely not on the retina. The image is formed in front of the retina. So answer C is correct. Image is formed in front of the retina. Okay, moving on to the fourth question. Fourth question says, if an object is placed at a distance of 20 centimeter from the optical center of this length of focal length 10 centimeter. So we have focal length as 10 centimeter. The object is placed at a distance of 20 centimeter from the lens, and let me give you a hint. We know that for object distance, it is always negative. Correct? According to the new Cartesian sign convention, what will be the sign of magnification in this case? Can you let me know the answer? Okay, you all the best for your maths pre-boards. Okay, answer is A. 02 is saying A. Aman is also saying A. Okay, let's see how to approach this question. You have focal length as 10 centimeter. That means the sign of focal length is what? Positive. And we know focal length is positive only for what? Only and only for convex lenses. Correct? For convex lens, my focal length is positive. For concave lens, focal length is always taken as negative. Now that I know that I'm using convex lens, I can see for magnification, we have formula V by U, correct? For the magnification of lens, we have this formula, correct? Now, for convex lens, U is definitely negative. And V for all kind of images. Now we have to see where the object is placed and where the focal length is. Now this is my convex lens and focal length is 10 centimeter. Correct? Focal length is 10 centimeter. Now the object is placed at 20 centimeter. So that means object is placed behind the focal length. That means the image will be real and inverted. Correct? Because only in 6th case, when the object is placed between optical center and focal length, only in that case my image will be virtual and direct. But here, in the case where the object is beyond focal length, the image will be real and inverted. Correct? Image will be what? It will be real and inverted. And basically I know for real and inverted, magnification is always negative. Correct? For real and inverted image, magnification is always negative. One more way in which you can say is definitely U is negative. So U is negative. And if V is real and inverted, that means V is on the right hand side of the lens. That means V is positive. So this is my magnification, which can clearly say positive divided by negative is negative. So the answer is negative. In fact, all the kids who said A as an answer, I'm really very proud of you. Okay. Ma'am, your hairs. What happened to my hairs? Okay. Let's move on to the next question. That is 5th question. The 5th question says, okay. Look at the question carefully, then you can resume your talking. The focal length of lens is 10 centimeter. Focal length is given as 10 centimeter. Write the nature of the lens and find its power. So can you let me know what will be the power of this lens and what will be the nature of this lens? Okay, your hairs. Thank you. Okay, answer people are saying, my kids are saying A. Answer as A. Classy is also saying A. Chirag is also saying A. Rohit is also saying A. Okay. If you all are saying, I can definitely agree that it's A. Let's just see how to do that. The only thing that you need to take care of in this question, that this is in centimeter. For power, we need to convert the focal length into meters. So focal length will be 0.1 meter, correct? And then we know that power is reciprocal of focal length. That is what? 1 by 0.1, that is 10 diopter. Now you can write diopter because now focal length is in meters. That is the only thing I need you to take care in these questions. Okay. Now, since again the focal length is what? Positive. So we just saw positive focal length is only for what? It is only for convex lens. For concave lens, focal length is always negative. So again, A is the correct answer. Very good. I'm so proud of you. Okay. Next question. Let's move on to the next question. That is sixth question. It says, okay, an important question, a very important, conceptually very important question. Okay. So the question says that the image distance from the eye lens in the normal eye, when we increase the distance of object from the eye, then what happens? The image, if this is my eye lens, if the object distance, object was here, then here, then here, or here, what will happen to the image distance on the retina if I change the distance of object? The image distance from the eye lens in the normal eye, when we increase the distance of object from the eye, increases, decreases, remains same, or depends on the size of the eyeball. C, we are getting answer as C. C. Okay. Yes. So, the image is being formed at retina. What kind of question is this? This is a PYQ question. The image is being formed at the retina. So, definitely, how much distance if I change of my object, it doesn't matter. Retina stays at the same place. My eye lens stays at the same distance. So the image distance from the eye lens will always be the distance between eye lens and retina. It will never change. It will always remain same. Correct? Okay. Remains unchanged. That is correct. Class A is saying मैं जादू कर सकते हूँ. I definitely want you to do जादू and get all my kids 95% in boards. Okay. Okay. Seventh question, it says, it asks, seventh question says, the power of accommodation of the lens is a very important property of the eye lens, which is mainly handled by which part? Vitreous humor, ciliary muscles, lens itself, or the cornea? What is the answer to this question? The power of accommodation of my eye lens is a very important property. Now this property is mainly there due to which of the part of my eye? Vitreous humor, ciliary muscle, lens itself, cornea. Everyone is saying B. Okay. Yeah, I was reading your name and I read ciliary muscles as class C, I guess. Okay, so exactly the answer is B. This is my eye lens and we know this is being held by ciliary muscles. Correct? This looks like a mushroom or something. And this is the eye. That's a very bad diagram. You practice in your home, okay? Okay, this is the eye lens and these are the ciliary muscles. These ciliary muscles are an important part of the eye which is responsible to hold eye lens, to increase or decrease the focal length of my eye lens, which is called power of accommodation of eye. Correct? Okay, let's move on to the next question. 8th. Okay, this is a really good question. I want you to get your pen and paper so that you don't make any mistakes. Some people were saying they can do it without paper. Let's do it without paper. Okay. The near point of the eye of a person, I think I forgot to give you options. The near point of the eye of a person is 50 centimeter. Find the nature and power of the corrective lens. We have to find the nature and power of the corrective lens required by the person to enable him to see clearly the objects placed at 25 centimeter from the eye. Can you solve this question? Yes, option A. I thought of giving you options for this numerical, but I didn't. Let me know if you can solve this or not. This question is a very important question. This is also a PYQ for CBSE. This is a very important. This requires just a little bit of your brain. Convex plus 2 diopter, everyone is saying. Let's see if they are correct or not. Let's see if you are correct. Okay, so what happens, I'll just tell you what's the one thing that you need to do. For the near point, every time the near point of a person changes, that means the given near point, that is 50 centimeter, correct? The given near point is 50 centimeter, that is our image distance. Because technically the near point should be 25 centimeter. Now it is not 25 centimeter, that means it is something else. So, but the person needs to see the object which is placed at 25 centimeter clearly. So the object is at 25 centimeter. Correct. The object is at 25 centimeter. The image, because my corrective lens will first make that image of that object at 25 centimeter. At 50 centimeter, sorry, which is the new near point of the eye, and it will make it in the same direction as that of the object. So both will have negative sign. Correct? Okay, both will have negative sign. So what will we do now? If you can find the focal length and then tell what kind of lens is this, but we can clearly see it is a defect of hypermetropia, because the person cannot see objects at 25 centimeter, near point has shifted. That means the defect is hypermetropia, and to correct hypermetropia we use convex lens. Correct? Understood? And let us just see, the focal length of convex lens should be positive. Let us see if my calculation will give the focal length as positive or not. Correct? So lens formula is basically 1 by f equals to 1 by v minus 1 by u. So 1 by v is minus 1 by 50 minus of minus 1 by 25. Correct? If I just take the LCM and solve it, this will be plus 1 by 50 centimeter. This is 1 by f. So this is, so focal length is 50 centimeter. That means it is 0.5 meter. Why did I convert it? Because I need power, and for power we need to convert focal length into meters. Correct? Now we just know power is inverse of focal length in meters. So this is 0.5 and this will be 2 diopter. And since the so we hence proved that focal length is positive, so our whole calculation is correct. So the option is definitely, whoever said power is 2 diopter and the lens that is used to correct this is what? It's convex lens. Correct? Okay. We are discussing about cats in our live chat. I have 2 cats, I have 3 kitten, Persian cat. Okay, रिश्ता भेज दो अब एक दूसरे को. Okay, next question is 9th question. Again, a really important question. A student needs spectacle of power minus 0.5 diopter for the correction of his vision. Name the defect of vision that student is suffering from. हाँ बेटा, कल एग्जाम है तो ये पढ़ के पास हो जाओगे. Definitely your exam questions will not come out of this lecture. The questions will be almost similar to the questions I have for you. Okay, we have one B option, one A option. Okay, A, B. Classy is still saying B. Okay, just the thing you need to do, power is, just see the sign of power. Power is negative. That means focal length will also be negative. It's just the reciprocal of power, so focal length will be negative. Correct? Negative focal length is for which lens? It is for concave lens. Correct? Because convex lens always have positive power. Concave lens is used to correct which defect? It is used to correct myopia. That is how you reach to your answer. Correct? Understood the chronology? You first start with the sign, then you go to the sign of the focal length. From there you understand which lens is this, because focal length is positive for convex lens and negative for concave lens. From there you see which kind of lens do we use for which kind of defect. For myopia we use concave lens, for hypermetropia we use convex lens. Correct? Okay, let's move on to the next question, that is the 10th question. Okay, a good question, conceptually strong question. It says, with the help of ciliary muscles, the human eye can change its curvature and thus alter the focal length of its lens. Correct? State the changes that occur in the curvature and focal length of the eye lens while viewing. How will my eye lens change? Will it get thick? Will it contract? Will the ciliary muscles contract? Or will the eye lens get thin? Will the ciliary muscles relax? When viewing for distant object and when viewing for nearby objects. Let me know the answer first, then you can go on with your chat. With the help of these muscles, how will the eye lens change when we see a distant object or we see a nearby objects? So, for distant objects, just remember in a way, if the object distance increases, focal length will also increase. Correct? For distant objects, object distance is more, so focal length increases, and when focal length increases, the eye lens becomes thin. Correct? That is thin eye lens. And similarly, then we can definitely see for nearby objects, focal length, what? Focal length decreases as the distance of object from the eye decreases, focal length decreases, and thus the eye lens get thick eye lens. Correct? That is it for this chapter. Nearby object, answer is increases for curvature and decreases for focal length. Yes, very good, Aman. That is absolutely true. For distance object, curvature decreases and focal length increases. Okay, ma'am new hu yahan pe. Hello, my new students. We are doing questions of human eye today. In this live, we have already completed for light, electricity, magnetic effects of electric current, and we will be coming with lots of new material for you guys for your boards. Okay, so make sure to join the WhatsApp channel and subscribe the channel. Okay, moving on to the next question, that is 11th. New point of a far-sighted person. Near point of a far-sighted person is 40 centimeter. He wishes to reduce it to 25 centimeter by using spectacles. What power and nature of the lens he should use? Let me know. I've asked you to keep a pen and paper with you. Let me know the answer to this question. What kind of lens and what power of lens a person will use if he is a far-sighted person? I'm waiting for you to solve the answers. Solve the question, sorry. We are doing this live today and we are doing numericals of human eye as well. Now we are in January, so I really want you to guys you guys to like buckle up and start your preparation. Do not do avaragardi. That's how we say it. You have plenty of time for that. So start your preparation today for your boards. Today we are bringing a lot of things for you. Ashutosh is saying A. And we have Adaman is saying 1.5 diopter with convex lens. That is the same as the Aman said. Okay, let's see if you guys are actually correct or not. So again, near point, when I said, I told you in case of near point, this is my image distance. So V is 40 centimeter. He wishes to reduce it to 25 centimeter. So the object is at 25 centimeter. Both are negative. By using spectacles, what power and nature of lens he should use? Again, very simple question. For power, we'll just calculate focal length with the help of lens formula. So this will be minus 1 by 40 minus of minus 1 by 25. Taking LCM, we can just take 200. That is minus 5 plus 8. That will be 3 by 200. And that will be 1 by f. So focal length will be 200 by 3 now. Correct? Okay, everyone has these answers. So focal length is basically 200 by 3, and that will be 6.66666. 66.666. Yes, that will be 66. Yes, 66.666 and stuff. Now this focal length is again in centimeters, so we convert it in meters. This will be 0.67. You can directly write meters. For power, just invert it, 0.67. That will be 100 by 67, or you can just write 0.67, and if you solve this, you will get something. Yes, very good, all of you. And you will get around 1.5 diopter. Correct? So power is 1.5 diopter. So either the option is first or second, but this is again hypermetropia. Correct? This is again hypermetropia. For hypermetropia, the corrective lens is what? It is convex lens. Very good. So the answer A was correct. Who gave it? Aman and one Ashutosh, I guess. मैं भी आज नया ज्वाइन किया हूँ मैम. Okay, hi Aman Verma. I'm very glad that you joined. Hello. I hope this lecture is important to you. I've brought you numericals as well as conceptual questions, and for that, in the khushi of you being naya, let's move on to the next question. That is 12th question, which says the near point of a person suffering from hypermetropia. Again, we have a question of hypermetropia. Why we have so many questions of hypermetropia? Because it can be a little confusing. So CBSE definitely wants to confuse you guys. So hypermetropia questions, these kind of questions of hypermetropia are a lot more than myopia. Okay, the near point of a person suffering from hypermetropia is 75 centimeter. Sorry. Calculate the focal length and power of the lens required to enable him to read the newspaper, which is kept at 25 centimeter from the eye. Now this question is similar to the one we just did and we did before. So I want you to solve this and let me know the answers as soon as you can. Now you know how to solve it. Why I brought 3 questions of the same type? Because it is repeated. Hence you can see these are repeated, because these are important and because I want you to practice them. These are very, very important. Let me know the answer. The required focal length is 37.5. And the power, okay, where are you copying this? Are Answers from somewhere. If I see the comment, I see the chat, it looks like it. Okay, anyways, क्या कैसे सॉल्व करती हैं? What happened? All person came to bank and asked their money. Okay, let's solve this question. Again, the question is near point. So 75 centimeter is the image distance. Calculate the focal length. We have to calculate the focal length. आ गया है. Reconnection successful आ रहा है. अभी देखना.
अभी नहीं आ रहा.
So what should I do?
हाँ.
Okay, अभी आ रहा है ना?
अभी आ रहा है.
हाँ, okay.
हाँ, अभी आ रहा है.
Okay. Hi. Hello everyone. I'm so sorry, there was some internet glitch, I guess. I don't understand why, because I'm not a techie. Hi, hello Vedansh. Okay, let me start again. We had a small internet connection. I'm so sorry for that. We are doing this question where we are given that the near point of a person suffering from hypermetropia is 75 centimeter. Calculate the focal length and power of the lens required to enable him to read the newspaper, which is kept at 25 centimeter from the eye. Hello Vedansh Avasti. So in the near point, I have told you the near point that is given is my V, and we have to calculate the focal length. The object is kept at 25 centimeter. Both of their signs will be negative, and by using just lens formula, putting these values, we will get focal length as 37.5 centimeter. Correct? If for power I need to change this focal length into meters, that will be 0.375 meters. So power will be just inverse of 0.375, and this will come out to be almost equal to what? कैसे हो मैम? I am great Vedansh. आप बताओ, how are you? How is your board preparation going? Okay, so this will be 1.5 diopter. Correct? If you think this calculation is hard, just do inverse of focal length. That will be 2 by 75, and then you can easily, so this 75 is in centimeters, you need to convert it in meters. That will be point, so that will be 200 divided by 75, and hence you can easily see this will be something around 2.6 diopter. Correct? If you don't want to do the calculation of 1 by 0.375, of course that's hard. Hi Vedansh. Repeat ma'am, repeat this question. So the question is asking that a near point of a person has shifted to 75 centimeter, and we need to calculate the focal length and power of the lens required to enable him to read the newspaper, which is kept at 25 centimeter. So normally the near point of a normal human eye is 25 centimeter. Now that person's near point is at 75 centimeter. So we need to see which kind of lens, what the power and the kind of lens he should use to correct his vision. So in the case of near point, the near point, a new near point that is given, that is 75 or 25, other than 25, other than that is 50, 30, anything other than 25, that will be taken as V, and the sign will always be negative in these kind of numericals. We have done three these kind of numericals because these are very important. Now U is definitely given as 25 centimeter. Even if in the case in these questions, if U is not given, you will take 25 centimeter U. Okay. Now using this lens formula, we can see we can calculate the focal length that we need to calculate. Correct? And this will be our focal length 2 by 75. If I this will be invert, correct? F will be 75 by 2. This is 75 by 2. So focal length comes out to be 37.5. And for 37.5, hi Vinod. Okay, you can just invert it and you will get the power. Clear, ma'am? Okay. Okay, let's move on to the next question. That is my 13th question, that says how the defect of vision where a person can't see far away object can be corrected by using concave lens, by using concave mirror, by using convex lens, or by using convex mirror. The defect is that the person can't see the object, far away object, clearly. Let me know what is the answer. Okay, so for these kind of questions we have clearly studied that far away objects, if a person can't see, that means it has myopia. Correct? That means it has myopia, and for myopia the corrective lens that are used for, the corrective lens is concave lens. For myopia, to correct myopia, we use correction lens as concave lens. Correct? Okay, moving on to the 14th question, that says assertion reason questions that are a very high chance is that you can get assertion reason question from this human eye chapter. Okay, so the question is, a person with hypermetropia cannot see nearby objects clearly. Okay, and the reason says the eyeball is too long and the focal length of the eye lens is too short. Is this correct or not? Assertion reason question. They are saying a person with hypermetropia cannot see nearby objects clearly, and the eyeball is too long and the focal length of the eye lens is too short. So in general, if you just give me this statement, the eyeball is too long and the focal length is too eye lens is too short, that does not make any sense. And this, so the first is correct. In hypermetropia, a person cannot see nearby objects clearly. Correct? So the first assertion is true, but the reason is not true and is definitely not the correct explanation of A. So A is true, but R is false is the correct answer for this particular question. Okay, moving on to the next question. Again, a good question, a conceptually good question. Let me know the answers if you can. Study the diagram below and answer the following questions. The questions are: name the defect of vision depicted in the diagram. This is the diagram we are given, and you have to show and you have to tell me what kind of defect is there in this particular question. Okay. So again, how to approach this? You can clearly see the image is not being formed on the retina. The image is formed behind the retina. It is formed behind the retina, and in case where image is formed behind the retina, that is, ma'am, definitely a case of what? It is a case of hypermetropia. Correct? In case of hypermetropia, where we can't see nearby objects clearly, that is when the image is formed behind the retina, hypermetropia. Aman is correct. Second question: how it can be corrected? Oh, we had options. So either of these, A or B, can be correct. Now answer me. How this defect can be corrected? Using convex lens or concave lens? Okay, Aman is saying A, Poonam is saying A. Yes, Aman, I saw your A. Okay, so definitely A is the correct answer, because for hypermetropia we use convex lens to correct the defect of hypermetropia. Correct? Understood? Yes. So that is where we complete our 15 questions of the day of the chapter Human Eye. We are done. We have completed the revision of physics of your class 10th boards. Started with light, moved to electricity, moved to magnetic effects of electric current, and then done with human eye. We have done almost 45 to 50 questions of these 4 chapters. Before that also we did lots of questions, around 80 questions of just physics. So if you do these questions only, you will be able to top your boards. I can guarantee you. I'm here to make you top your boards, okay? Yes, because the image is formed behind the retina. Aman, very good. That is where we end our live. Make sure to join our WhatsApp channel, because we are coming live every day for all the subjects. We are revising all the subjects. We are almost done with the revision. Then we'll come with more revision for you guys in the form of papers, so that you can score 95% in your class and boards. I know it's very important for you guys. So make sure to join this WhatsApp channel. There is a link in the description. And subscribe the channel. And if you have any doubt, if you don't have any doubt, we can stop this live. Okay, it's almost hour and a half. Okay, that is it for this live session. We'll meet you in the next series, in the next live. Till then, tada, bye bye.